Welcome everyone. Now let's talk about the arithmetic operators in Java. So there are 5 arithmetic operators. They are addition, subtraction, division, multiplication, and remainder, or also known as the module. Okay. So those arithmetic operators, they are the binary operators and used for performing the fundamental arithmetic operations, or you can also see them as the basic mathematical operations. Okay. So we do have all those 5 operators in algebra. The addition in algebra means getting the sum of 2 numbers, right? And subtraction means in algebra, it is going to subtract one number from another. Then it will return you the subtraction result. In Java, it is also the same. And this division, it is going to divide one number by another number and then returns you the division result in algebra. And in Java, it also does the same exact thing. Okay. And then the multiplication, it is used for multiplying 2 numbers and return the multiplication result at the end. And then lastly, we have the module operator, one of the basic mathematical operation. So in algebra, every time when one number is not evenly divisible by another number, then there will be some leftovers. Okay. Then your division result will be some decimal numbers. Every time when there is a decimal numbers, that means there is a remainder, and the remainder is not equal to 0. Okay. So in order to calculate the remainder, we could use this module operator, which will return us the remainder. For example, suppose that I wanted to find what the remainder of 11 divided by 3. So I could just apply this module operator in order to find out the remainder, the ones that is left over. So when we divide 11 by 3, the remainder will be equal to 2, which means it is not evenly divisible. 11 is not evenly divisible by 3. That's why we have a leftover of 2. So this remainder operator, or also known as module operator, it can be used for testing whether a number is even or odd, and it can also be used for finding the individual or a group of digits from a number. Now let's take a look at this task of the arithmetic operators, where we need to calculate the addition, subtraction, division, multiplication, and remainders. Now let's create the package in our IntelliJ and create a new class for this task. So please open your IntelliJ and create the package under source folder, name it module 11 operators part 1. And please create the class named arithmetic operators. Arithmetic operators. Okay. And let me create this main method so that the class becomes runnable. And I'm going to give all those expressions in the print statements. Then we are going to analyze what will be the output. So you see every single one of those arithmetic operators you are applying to 2 operands, right? So when you apply the arithmetic operators to the 2 operands, at the end you will get a new data. That new data, it can be passed in the print statement. So therefore, if I have this print statement, I could pass the 2 operands and operator in this print statement right here, such as 10 plus 5. You see, this is the addition operator. This operator is applied to those 2 operands, and then it is going to return me a data, which is 15, into new data, which is 15. And 15 will be printed by using this print statement. So when I run my program, I am going to get 15 on the console. Okay. And let's do the next one. Next one is 10 minus 5. So the next, so here I'm going to do the same thing. Here's my first operand, and then I will apply the minus operator, the subtraction operator, and then I will give my second operand afterwards. Okay. So the result of this operation is going to be 5, right? 5 will be printed by this print statement. So when I run this program again, I am going to get 5 on the console for this operation. So this addition and subtractions are the way that it works in Java are exactly the same the way they work in algebra. Okay. And then next we have the division operator. So as for this division operator, in Java, the numbers, the elements, they do have data types, right? So if you give this 10 divided by 5, this operation here, this division operator is applied to those two numbers. One is, both of them are integers. So if you divide the integers by integer in Java, then you will get integer result at the end. So therefore, my output is going to be 2. Okay. And since the data type does matter in Java, when you have integer numbers like this, for example, suppose that I have this 10 divided by 4. In algebra, you're supposed to get 2.5, right? In algebra, when you divide 10 by 4. But in Java, you see, since this is an integer and this is also an integer, integer divided by integer will give you integer result in Java. So even though the actual result is supposed to be 2.5, the actual calculation result is supposed to be 2.5 in algebra, but in Java here, you will only get the integer value, which is 2. The decimal number will not be included. And what can I do if I want to get the exact decimal result for the division? What you can do here is you need to make sure that either the numerator or denominator is a double. It needs to be a floating point value. Then you will get the floating point value in your from your division, from this division result. So, for example, if I use this division operator to divide 10 by 4, if I just leave it as 10 and 4, it's still going to give me 2. In order to make sure that it will give me the 2.5 result, I could make the numerator to be a double, or I could also make the denominator to be a double type. You see? Then I'm getting 2.5. This is one way that you can make the numerator or denominator to be a decimal number. And another way is, so if I have this 10 divided by 4, right? To make sure that this is going to be a double, I could add the lowercase d or uppercase d character so that the compiler will take this number as double data type. Then double divided by int, it will give you double result at the end. The only time that you will get the integer result when you use this division operator is if both numerator and denominators are integers. If both of them are whole numbers, your division result will also be whole number. So here I will get 2.5 if I run the program. See? So this is the division operator. And the next is the multiplication operator. So for the multiplication operator, we do have this expression, 10 multiplied by 5. So 10 multiplied by 5, it will return us 50. So if I run the program, I will end up getting 50. Okay. So these are the addition, subtraction, division, and multiplication operators. And the last one, the one that is the most challenging one, is the module operator. Okay. The last one, which is also the most challenging one. So let's analyze this module operator one by one. Okay. Suppose that I want to find out what the remainder of 10 divided by 3. So to find the remainder of 10 divided by 3, for those two operands, I will apply this operator. Okay. So this operator, first of all, it is going to divide those two numbers, and then it will return whatever is the one that is left off. So if you run the program, you see the left off is 1. This is the leftover after the division. And let me show you how did we get this number. So when you divide 10 by 3 in algebra, 10 divided by 3, it would give you a number like 3 point, numbers like this, right? So every time when you see those numbers in the decimal sections, that means there is a remainder. That means that 10 is not evenly divisible by 3. And in algebra, this is how the remainder is calculated. Okay? From the numerator, which is 10, you will subtract the multiplication result of denominator and integer value from the result. Okay. So our denominator is here is 3, and the integer number in our division result is also 3. Therefore, our output is going to be 1. 10 minus 9 will give you 1 at the end. Okay, so this is how we ended up getting the 1 as the remainder. And let's also do a couple more examples of this remainder operator. Now suppose that I want to find out what the remainder of 10 divided by 2. So I will apply this remainder operator to 10 and those two operands. At the end I will get 0, you see. Because when you divide 10 by 2, you will just get 5. There is no decimal numbers afterwards. Which means it is evenly divisible. If it is evenly divisible, the remainder will always be 0. Okay. And here's one more. This time we need to find the remainder of 9 divided by 2. Okay. 9 divided by 2. So when you divide 9 by 2, you will get, in algebra, you will get 4.5. So the integer result in from the integer division result is 4. So 4 multiplied by 2 is going to give you 8. And if you subtract that 8 from 9, then you will get your remainder, which is 1. Okay. And of course, in order to calculate the remainder in Java, we don't need to go through all those formulas. We can just use this operator to get the remainder. But make sure that you know what remainder is. Okay. And what if I have, next expression is for the remainder of 14 divided by 2. What if I apply this remainder operator to 14 and 2, those two operands? 14 divided by 2 will give you 7. The integer number 7, right? There is no decimal sections, which means it is evenly divisible. So if it's evenly divisible, then the remainder must be 0. Okay? And then the last one that we have is 1234 and 10. We need to apply this modulo operator to those two operands. So let's see what what's the remainder when we divide 1234 by 10. The remainder is, as you can see, it is 4. Okay, so this is how the remainder is calculated. And here's the next task. Whenever you are using those arithmetic operators, keep in mind that the arithmetic operators, they will give you a new data. If you apply the arithmetic operators to the variables, the arithmetic operators are not going to change the actual value of the variable. The only time that the value of the variable will be changed is when you reassign the variable. So for example, you see, here I declared this variable chairs, and first time I set 40 to it. Which means in the memory, there is a variable chairs created and 40 is stored into this variable. And in the next statement here, I am adding 2 to the variable chairs. I use this arithmetic operator to add 2 to the variable chairs. The value of the chairs is 40. 40 plus 2 will give you 42. Okay, 42. But this 42, it doesn't mean that it is the new value of the chairs, because we haven't reassigned this variable chairs yet. So which means after this line, if you print the chairs, the value of the chairs is still going to be 40. Okay, so the value of the chairs is still 40. So if you add 5 to this chairs, to this variable chairs, then you will get 45. Okay, 5 is added to this chairs variable, which give you 45. But it doesn't mean that 45 is the new value of the chairs. Okay, it's not the new value of this variable chairs, because we haven't reassigned this variable yet. This 45, now we stored it into this variable more chairs, which means the value of the more chairs will be 45. And as for the value of the chairs, it is going to be 40. Okay. Let's also do this practice real quick. In the IntelliJ, please create a new class named operator assignment. Okay. And create the main method. So this is our chairs variable now. and first time it's set to 40. Okay, and then we have this print statement, which we are using this addition operator and applying it to the operand chairs and also to the operand 2. Okay, so those two are operands now. So when we apply this plus operator, it is going to get us 42. This operator is returning us 42. But is this 42 the new value of this variable? The best way to find out would be by printing this variable chairs. See, when I print the chairs, when I call the chairs, I'm still getting 40. Because I haven't reassigned this variable yet. If you do not reassign the variable, then the original value will still be stored into the variable. Okay. And then next step we have this plus operator, which is applied to chairs and 5. Okay. This plus operator is going to return us what? 45, right? And this 45, it is being stored into the new variable named more chairs. Okay. So if I print this variable more chairs, you see, we're getting 45. Because this addition, it will give us new value, which is 45. But does that mean that 45 is also the value of this variable chairs now? Have I reassigned this variable chairs so far? No. Which means the value of the variable chairs will still be 40. Okay, so if I run this program, you see, I end up getting 40 here. So make sure that you do know what this assignment operator is for. And if whenever you use those arithmetic operator, apply them to the variables, it doesn't mean that it is going to change the value of the variable. The only time that the value of the variable will change is when you reassign the variable. Otherwise, it will not be changed. Okay. And then the next, we need to know the precedence of those arithmetic operators from highest to the lowest level. So in Java, the one that has the highest precedence, the operator that has the highest precedence are the parentheses. Okay, parentheses has the highest precedence. Just like in algebra, every time when in algebra, if there is parentheses that is being used, whatever was in the parentheses would be calculated first, right? In Java, it's also the same. And then next we have this multiplication, division, and remainder. They have higher precedence than the addition and subtraction. Okay. So which means if one of the calculation it includes multiplication, remainder, those operator, and also addition and subtraction, that means those operators needs to be calculated first. But what if our expression it is using multiple of those operators, multiplication and the division? Then the execution order will be from left to right. So from left to right, whichever of those operators are given first, that's the operator that gets executed first. And out of those arithmetic operators, the addition and subtraction has the lowest precedence. Okay. And when you are using addition and subtraction together in one expression, the execution of order of those operators will still be from left to right. Okay. So let's take a look at some of those examples. Suppose that I have this expression which is adding, which is 12 plus 6 minus 3. So this addition and subtraction, they both have the same precedence, right? But now, since they are going to be executed from left to right, therefore addition will be executed first, then the subtraction will be executed next. So when the addition is executed first, it is going to return you 18. And then when the subtraction is executed, it will return you 15 at the end. Okay. And what about here? Here I have the addition, division, and subtraction. Even though this addition is the first one that I give from left to right, but it has a lower precedence than the division. Since division has the highest precedence, it is going to, the order of the division is higher than the addition and subtraction. So it will be calculated first. Okay. When this division is executed, it's going to return us 2. And now we have addition and subtraction. Since they both have the same level of precedence, now the execution order will be from left to right, which means addition will be executed first, okay, which gives you 14, and then the subtraction, which gives you 9. And of course, if you have the parentheses in your calculations, the parentheses overrides the precedence of all the operators. Here I'm using this parenthesis with the multiplication operators, so which means this parenthesis now overrides the precedence of the multiplication. So here you see whatever is in the parentheses, it will has the highest order, it will be calculated first, then the other operators. Here it multiplied the 3 to 3 since they are in the parentheses, then it execute addition. And then here in the second example, you see it got the addition first, 2 plus 3 since they were in the parentheses, then it calculated the multiplication. Okay, thank you so much everyone, see you all in the next video.